for this opportunity to speak about quantitative data analysis with SPSS. This is really a topic that for me, I love this. I really enjoy working in SPSS. Doing data analysis is really something that I really do enjoy, but I know that not everybody sort of feels comfortable with statistics and all of that. So the purpose of today's session really is to focus on basic data processing. And I think for all of you that's supervising master's degree students who's maybe doing a quantitative descriptive study, really all that you need for a quantitative descriptive study is to do basic data processing and descriptive analysis. So you really only need a statistician to assist you if you will be doing inferential statistics, statistical tests, and so forth. So for today's session, we will focus particularly on how do we handle the data itself and checking for errors, and then performing basic data summary analysis or descriptive analysis. And then I also just want to briefly touch on how do we do a reliability analysis of scales. And then maybe after the session, you can tell me your needs in terms of further content related to SPSS. So it is quite difficult to condense something like SPSS in an hour. So really, I will just briefly touch on most of the things. And if you need more detail about it, then it would maybe be good to join the second year students during the March workshop when I do a few days of SPSS with them. You can also access courses on SPSS. I think they used to provide it on main campus. I'm not sure if they still have some of those courses on main campus available. So can I just get an indication of who of you were actually able to download SPSS on your computer? If you can just give me an indication of hands, you can just put your hand up if you were able to download it, so that I can just get an idea of going forward with this session. I don't see any hands, so it seems as if there's nobody who actually were able to download SPSS on your computer. Can I maybe just ask if you want to put in the chat? I know Santal said it's because she had problems installing, and Mariana said it took very long to download. Any other problems that you had with actually downloading and installing SPSS that you think we should address? I see Cornell is typing. Okay, so you have it, Cornell. Great. Were you able to open the file that I sent, Cornell?
No, Talita, I haven't tried yet.
Okay, so you can maybe open that in the meantime if you can. Okay, nobody else is commenting. So I'm assuming that most people just maybe didn't have time to download it, or you are still in the process of downloading it. So what I will do is, since most people did not do it, we will, the activities you'll see that we'll do today is very basic. So I will take you through it, and then maybe once you've downloaded it in your own time, then you can go through some of those activities. Okay, the file doesn't open. Okay, that is strange. Okay. I think, yeah, because I think the whole purpose for me was to give you some activities to do so that you can build your confidence in working in SPSS, because sometimes something can appear very daunting until you actually do it and you see that you are able to do it. I don't know if anybody has some background experience of working in SPSS. Anybody who's previously undergone training in SPS, if you want to just put your hand up. I also don't see any hands. Oh, Mariana and Cornell. Okay, great. Okay, so let's proceed. So just briefly to summarize again for you the stages of data analysis. So firstly, we will preparing our data for analysis, and that includes entering the data, cleaning it, and correcting any errors. And this first step is very important because what the statisticians usually say is that it's garbage in, garbage out. So if you don't check your data and check that those are proper data that you are using, or there's errors in your data, then you won't be able to make proper conclusions from that. Cornell, I'm just going to quickly upload the example data set here in the chat so that you have it if you want to open it. Then the second step would be describing the sample, and this is basically where you, for each and every variable, will go and do a descriptive analysis and then present that. The third step is testing reliability of measurement methods, and this is if you have specific measurement scales that is suitable for reliability analysis, and I'll speak about that. So we will cover today the first three steps in the stages of data analysis. The fourth and the fifth step is more got to do with when you have hypotheses. So if you have an hypothesis that you want to test, or you want to look for associations between variables, this is when you will then firstly conduct exploratory analysis, and then you will confirm your analysis with specific statistical tests. And this is where you will then interpret p-values. Okay, so the first step is preparation for the data for analysis. So these days, we get various ways. If you have a student who's doing a descriptive, a quantitative study, they can use REDCap, which is a data management system from the university. It's quite, there's a lot of access control on the system. You can set the questions, you can enter it onto REDCap, and then the REDCap sends out, you put the list of participants, email addresses in there as well. REDCap then sends out the surveys, and the participants respond anonymously, so their response is not linked to their email address. And then you can download the data. So REDCap then captures it in a database. And then you can download that as an Excel file, or you can download it as an SPSS file and then further work on it as a SPSS file. You can also use Sun Survey. So Sun Survey is similar, where you capture the data and then you download it as an Excel sheet, and then you can import it into SPSS. Now, in terms of some of the students still use hard copy questionnaires, so then they will have to create a data entry template on SPSS, which I usually show them in the March workshop how to create a data entry template, and then they enter their data into the SPSS. So when they do manual data entry, this is where we really have to check and make sure that there isn't any unnecessary errors. So in terms of then checking for errors, we can do random sampling of cases, we can select random numbers, and this is then where we basically select, say for example, we have 100 participants, then we can set the computer to select 10%, which is 10, and then those 10 we can check against the original questionnaires to see whether the data has been entered correctly. We also check the data by just looking at the variables that are entered itself, and I'm going to show that to you now. And then we also need to check the coding of the variables, and we need to recode if that is needed. And so I just want to quickly show you. So the activity here is to open the SPSS file that was emailed to you. You need to explore the different views, data view and variable view. You need to look at the different variables, nominal, ordinal, scale, as well as the coding of the variables. Then you have to do a random sample of 10% to check for errors. And then you need to remember to go back to select all. So this is what I want us to do together. I just want to share a different screen now. Okay, so let me quickly go. So if you open the SPSS file, and hopefully you can see now the file that I'm showing here for you. This is the example data set. In SPSS, SPSS looks a lot like Excel. Specifically when you're in the variable view, but you will see down here, there's two types of views. There's a data view and a variable view. Okay, so the data view looks a lot like Excel. The top row is all your variables, and if you name them very nicely when you set your templates up, you will see it's fairly nice to distinguish. So here you will see now, you guys have not seen the questionnaire, but you can get a fairly good idea from just looking at the variables. So the first column, we've got age. So we're assuming it's the age of the participants. And if you scroll all the way down, you will see that we have 320 participants in this particular study. Okay. Then we have gender. Okay, employment, the last viral load. So this was one of my students' work that I just reduced a little bit. I deleted some of the variables. And then we have a few items, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I think. That 10 items that are supposed to measure patient satisfaction. So you will see that it's complaint procedure and so forth and so forth. So this is where the data is entered. Okay, and one can shift between seeing the actual information here to looking at numbers. So when we work in statistical programs, we don't work with words, we work with numbers. And this is what we mean by coding. So you will see that, for example, all the females were coded 1 and the males here were coded 2. And the same with employment. Employment was coded, and then also the Likert scale items on this satisfaction questionnaire was coded. So if we go to variable view, this is where we create a template. So I will usually teach the students how to create a template in SPSS. So you will see that the first variable, so here the variables, every row represents a variable. So age here is the age of the participant. This is the label. You don't have to worry about these things now because we need a bit more time to go into all of that. So the age of the participant, and here when it comes to measure, your variables are either a scale, which means this is now a number. We also can say, well, this is either interval or ratio. So either interval or ratio data or the numbers are measurement. The measurements is a scale measurement. Then we get gender. So gender here in this, the values or the numbers that we've given to gender here is 1 for female and 2 for male. Now these numbers don't really mean anything. They just represent categories so that the statistical program can distinguish between the two. So in SPSS, if we've got different categories that are completely different, they're not related to each other, we call this a nominal type of variable. And you should know this from your previous research studies. If For example, this one is employment. So the options that we have here is full-time, part-time, and unemployed. Okay. And in this scenario, we labeled it an ordinal level variable because it sort of moves from full-time, then part-time, and unemployed. Ordinal doesn't mean that there's equal distances between these variables, but just that they are in some sort of rank order. And then if you look at these 10 items here, complaint procedure, cleanliness of the facility, confidentiality, respect, and so forth, waiting time, the values here is a Likert scale. So this is a 5-point Likert scale, and it's also an ordinal level variable. So it goes from very satisfied to very dissatisfied. Now here you also need to look at the coding. So for example, a higher number would indicate more dissatisfaction. And in this case, you could have actually had it the other way around to have a 1 very dissatisfied and a 5 a very satisfied. So that sometimes helps better to interpret some of the values when you get to the some of the analyses. Okay, so this is about the variable view and the data view. Can I just quickly ask if there's anybody who wants to ask a question about this? The variable view and the data view. So when your students send you this file, you will open it, you will first go to variable view, you will look at the labels, and these are all the questions. These labels are all the questions in the questionnaire, okay? And then you need to look at, okay, did they code it and did they properly code it? And obviously the statistician will also help with this, but as a supervisor, you really also need to make sure that your students' data is correct. Then if you go to data view, we can sometimes just go and look and see, yeah, we can see there's a missing value, there's a missing value, there's a missing value. So the first thing that we need to ask our students or ourselves when we see a data set with these open spaces is this a true open space? Did the person leave it open? Or is it a problem with data capturing that we forgot to capture that specific value? Okay, so let me just quickly go back. Any questions that you have at this stage of just briefly checking the data? Okay, so let me then just quickly go back. Now, say for example, so the gold standard of data entry is double data entry, where 2 people enter the data and then you can compare. Now, for students, most of the time this will not be possible because they just don't have money to pay somebody else, or there's no time. So what you can then sometimes do is to select 10% of your sample, of your participants, and then check that against the original questionnaires. Okay, so if you want to do that, you go to data, and then you can say select cases. And then you will see these various options, and you can see which you can choose a specific variable if you really want to. But we want to go down and select a random sample of cases. And then you will see it highlights this little button that says sample. And then in here you can say, well, you can decide 10% or 20%. So usually we do 10%. And then if we find a problem with 10%, then we can select more. You can also select an exact number if you want to. And you can say from where to where you want it selected. So, but we're going to select 10% of all cases. And we're going to say continue. And then we will say, okay. Okay, so what you see here is the SPSS output window. This is usually, and you will see just a little bit now when we start doing the descriptive analysis, the descriptive analysis will also output in here, and it creates a log of everything that you do in SPSS, and you can just minimize that, and then you go back to your data view. All right. So what you will see here on this side is that there's quite a few scratch out. So if the number is scratched out, it means it was not selected. So if, for instance, the computer selected participant 9, participant 12, participant 20, 29, 32, and so forth. So what you will then do, or have your student do, is to go to participant number 9, making sure that you've actually numbered the raw questionnaires so that there is a numbering link to the data file. You can also enter a separate variable here for the participant code to make it more clear for you. But you will go back to number 9, and then the student actually needs to check exactly whether there's any mistakes in the data entry here. All right. If they find any mistakes with the first 10%, they actually should continue with the next. They should actually select another 10% and do the same with that. If they find any systemic errors, then you actually need to check the whole data set. So by systemic error, I mean that, for example, instead of putting very satisfied a 1, they imported a 5 for all of the participants, and this happened to me in my when I did my PhD. One of my data capturers wrongly captured the COSA questionnaires on the Likert scale, so I had to physically go through and recapture and make sure that everything was captured correctly. Okay, you can also, so if you need to take this back, so if you keep it like this, SPSS will continue to do data analysis only on a 10% sample. So you actually need to go back to data, select cases, and then select all cases and say okay. And then if you minimize this, you will see that now all cases are selected again. You can also, for example, use the sort function. So if you go to data and you say sort cases, it's very similar to Excel. Let me just say sort cases. So say I want to sort age in ascending order, just to see if all of the ages fall in, my inclusion criteria age, because then I can see if there's any mistakes. So you can see here that there is 1, 2, 3, 4 participants where no age was captured. So here, I think what I did is I actually deleted the participant codes for these ones. So you should actually then have another variable here with the participant code so that you can go and see, okay, was this truly left out, or did you just forget to capture it? And then you can go down to see, okay, so is all my participants adults? Because I assume this was adults. And you will just go down to see, okay, is there any ages that seem to be sort of out of the normal range? All right, so this is just some ways to check your data. I cannot emphasize to you enough how important it actually is to make sure that you check the data before it is sent to the statistician. Because the statisticians do not have time to check data. They will maybe tell you, okay, there's something wrong with the data, it's not been checked, but it's not their job to actually check the data to make sure that it is correct. Okay, so any questions up until here? Okay. So that then was the data entry and then preparing the data for analysis. Okay, so then we're going to go to descriptive analysis. So this is now where you will describe each and every variable on the questionnaire that the participants had to complete. And this is now not yet, this may be if you have descriptive, you're doing a purely explorative descriptive study, then your analysis will actually end a descriptive analysis. You maybe only want to describe the attitudes or the knowledge of nurses regarding a certain thing, and then that is really all that you need to do. So when we do descriptive analysis, there's a certain way how we summarize and present categorical variables, and this is usually done in frequency tables, percentages, cross tabulations, bar graphs, bar charts, and so forth. So one example of a frequency table, I'm sure you've seen this before, males, females, the number and the percentage. If we want to make a bar chart from that, it looks more or less like this bar chart. So you have to decide, and the student have to decide in the chapter 4, how do they want to present the data? Do they want to do frequency table? Do they want to do bar charts? It can be a bar chart or a pie chart or any type of chart. Now I will show you now. And then we also get this, what we call cross tabulations. So cross tabulation is still descriptive analysis, but in this case you will see that we don't only have males and females, but we also have here the categories of the number of years that they worked in a certain in terms of, this was managing patients with HIV. So you will see, for example, here that if we want, a cross tabulation is usually done before we do statistical analysis to see if there is possibly associations or relationships. So you will see, for example, that we had only 6 males in the sample versus 70 females. Okay, and then in terms of the number of years experience, we see here that 19 nurses, or 27%, had more than 5 years of experience, where only 16% of males had more than 5 years of experience. But if we look in general, it seems as if for both categories, most of the nurses had between 2 to 5 years of experience. I hope you can clearly view that. So really descriptive analysis of categorical. So again, coming back to categorical variables. So categorical is any variable that can be in categories. So male, female, the same here with these type of ordinal level scales. They also categorical variables, or patient satisfaction scales. All of those things are categorical variables. And so we summarize them in frequency tables, charts, or in cross tabulations. So let me go quickly. Then we're going to the descriptive analysis of continuous variables. So a continuous variable now is the scale variables that we used that I showed you in SPSS. They are either interval level or ratio level. And for them, we summarize and present them with means, medians, modes, standard deviations, range, 95% confidence interval, interquartile range, scatter plots, histograms, box and whisker plots, and so forth. There's so many ways of summarizing it, but it's important that you select the right, the correct method of summarizing and presenting for the particular variable. So in SPSS, you will see something like this. If we have age, the descriptive statistics will be the N value there is 83, so that's 83 participants. The minimum age was 27, the maximum was 55, the mean was 37.8, and then that's the standard deviation. So that is how SPSS sometimes summarizes it. Sometimes they can give you the age as well if you select that the range as well if you select that option. You can also summarize using histograms. So continuous variables can be summarized using a histogram. And this is a histogram of age. And you will also still see that they do give you the mean age and the standard deviation there on the side. You can select to have a normal curve plotted to see how normal your data is distributed. So when it comes to a normality, if your data is normally distributed, we can usually do our parametric statistical tests. And you will find that the statisticians will usually do tests for normality to decide on your continuous variables, to decide whether they're going to do a parametric or non-parametric statistical test. But that is now not for today's session. But this is why we tend to put the normal curve on here. And you can clearly see that obviously this data doesn't fit the normal curve, but it's also because the sample size is quite small, so it's only 76. Another way of representing continuous variables is doing a box and whisker plot. So in a box and whisker plot, what you see is the middle, the middle box. That's the middle 50%. Okay. And the line, obviously the whiskers on the side, this is the range, the minimum to the maximum. And then you will see that the middle line, that you see the line in the middle of the box, that's the median or the 50th percentile. And then the lower bottom here, this is a 25th percentile, and the top line of the box, that's a 75th percentile. So the box here represents the middle 50%. And so this is also sometimes another way of just presenting your continuous data instead of sort of doing just a normal minimum maximum way of standard deviation and mean and so forth. So for data that is normally distributed, okay, we tend to use the mean. Data that is non-normally distributed, we tend to use the median and the interquartile range. Okay, and this is usually, and you can maybe go and read up about this, is because in data that is not normally distributed, we have a lot of outliers. The mean is not really an accurate representation of, what is the actual value that's in the middle of the set of numbers. And this is where we tend to then use the median and the interquartile range. Okay, so the activity that we will be doing is that we were going to look at one categorical variable. And we're going to produce a frequency table and a bar graph with that. And then I want to quickly show you how to copy that in MS Word as well, because it's really easy for your students then to copy it and edit it further in MS Word. And then I want you to identify one continuous variable, and then we're going to do explore that and look at the mean, the standard deviation, and so on. And then we will also be producing a histogram with a normal curve. So for that, I just now quickly have to go out again and share my screen. So when we do descriptive analysis in SPSS, we go to analyze. We always go to analyze. Then you will see, you go down, you will see there's descriptive analysis, descriptive statistics. So for frequency tables, we're going to select frequencies. This is now for the nominal level variables. Okay, frequency. So for example, I would have wanted you to choose which ones there are, but for lack of time, I'm going to select gender. So you can either click on it and drag it, or you can just click on it and click on this little arrow here to put it to this side. All the variables that is on the right side is the ones that will be analyzed. Obviously, all of these variables about the Likert scale items, you can also take to this side because they are all nominal or ordinal level variables on which we can do frequency tables. So I'm going to click on chart. Sorry about that. And then I'm going to select a bar chart, but you can also select a pie chart. It doesn't matter. Okay, we're not going to do a histogram because the histograms is for continuous variables. Okay, so the chart values we can select whether we wanted the frequencies or the percentages. So I will select percentages. Then you say continue, and then you say okay. Okay, so what you will then see here is the frequency table of gender. So you will see that we've got in total 320 participants. There were 4 missing. So for 4 participants, no gender was completed or filled in. So we actually, for this variable, we only had 316. So this is the difference between valid percentage and cumulative percentages. So you must just take note of that, the percentage and the valid percentage. So if you will be reporting on this, or your students will be reporting on this, we will usually look at the valid percentage. So we will say, okay, for this variable, 316 participants answered it. That is not 100%. 75 were males, that is 23.7%, and 241 were females, that is 76.3%. And then for the employment, you can look at the same, all of them completed employment. So you will see that sometimes the total differs depending on the number of participants that missed, if there were some missing values. So sometimes you expected to also report on the missing values, and then you will use the this percentage column. Okay. And this is then our bar chart that was now produced by SPSS. If you want to copy this in Word, and you can edit it in SPSS, but I usually tell the students don't copy it in Word and edit it in Word. So if you say right click and you copy it as, you have to copy it as a Microsoft Office graphics object. If you select that and you close it and you go to Word, I think I've got a Word document open here. If you then go to Word and you right click and you paste it, it copies it very nicely into Word, and then the student can actually go here and they can change the headings, they can change the type of chart, they can even make it, instead of a bar chart, they can make it a pie chart, for example. So this is, I usually tell the students to not do any editing in SPSS, but to rather copy it onto Word, and then they can do very nice editing of their charts and so on in Word. All right. So that was then the categorical variables. All right. So now we're going to do the continuous variables. So with the continuous variables, we go analyze, descriptive statistics. Okay. We can also do frequencies. Let me just quickly show you. If we do frequencies and we put age and we select charts and we say histogram and selecting the normal curve, this is where you will see this curve, and you can see this is, and this is just one example to see that the larger your sample size, especially with a variable like age, the more likely your data is to follow normal distribution. All right, so this is an example of producing a histogram with a normal curve. You can also go descriptive statistics and go to descriptives. If you go to descriptives and you select age, I can also select last viral load because that's also a continuous variable. You have various options here, mean, standard deviation, and so on, range. You can select whatever you want to include. And then you say, okay. And what it then does is it produces a descriptive statistics summary table where you have your N value. So you will see here, for example, that we only, for the last viral load, we only had 308 participants who had a viral load, and we only had 316 who had an age. This is the range, and so you can obviously see with viral load, there's a huge range. So the minimum and the maximum is hugely there's a huge difference. So it's very likely that the viral load values will be very skewed. And okay, so mean, median, standard deviation, you will see here. So I just want to show you again, if we do frequencies on the viral load, you will see the same. You will see that there is really a huge skewedness when it comes to viral load. There's extreme outlying variables. It looks very strange. Yeah. Okay, so another way to do the descriptive statistics of the continuous variables is to go to explore. If you go to explore, there's quite a lot of options there. So we're going to click on age and viral load. The statistics, the plots, you can click if you want normality plots, things like that, but that's not for now. So let's just look at that. So when you click on descriptives, it's quite nice because it gives you the mean. It gives you the 95% confidence interval of the mean. So the 95% confidence interval mean that we can be 95% confident that the true mean age lies somewhere between 38.39 and 40.48. Okay, but the actual mean that we had was 39.43. And then we've got the standard deviation there of 9.2. So you either report the mean and the 95% confidence interval, or you report the mean and the standard deviation. But you usually have to report because the confidence interval around the mean and the standard deviation gives you an idea of the variability of your data. How confident can you be? So if you look at this confidence interval, for example, between 38 and 40, it's quite a narrow confidence interval. So it tells you that we can be fairly sure of our mean that we had here. The wider the confidence interval, the more uncertain we are actually of our true values. And you can see that here with the viral load, which got a minus to a plus confidence interval. That's very, very wide. And so you can see a lot of variability in the viral load there. Okay, so that is really all I wanted to. This is a box and whisker plot for viral for age. And these dots here at the top represent outliers. So you'll see that there's a few participants that's quite older. But then the median age is about 38, which is very similar to the mean. And the closer the median is to the mean, the more likely your data is to be normally distributed. And you'll probably see a very different, far different situation with viral load. Okay, so that was the viral load. I hope you got the continuous variables. I hope that you're also with me. You are so quiet, and we have so little time. But so then, just the last thing that I wanted to talk about was then reliability testing. So once you've done descriptive analysis or basic descriptive analysis, you may want to now know, like, how reliable was my scale? So in this instance, we had a patient satisfaction scale, and sometimes we want to develop like a patient satisfaction score by adding all the answers of the scale. But we need to make sure that our scale is actually reliable. So for reliability testing in surveys, we usually use the Cronbach alpha. There's other reliability methods, for example, test, retest reliability and all those, but mostly we use the internal consistency reliability, and which is the Cronbach alpha. Okay, and so what that basically is, it helps us to establish to what extent the measure is a true reflection of a subject's responses. So the reliability usually should be 0.7 at least, and this means that 70% of the time we can trust that the score to accurately reflect what is being measured. Okay, so an example that I gave here for you was a scale that I extracted from my PhD that measured quality of life. So you will see that there is 1, 2, 3, 4 measures items in this scale. And what we want is we want to know whether all of these measures actually accurately measure quality of life. And you will see here that there were 5 items, and the reliability statistic says 0.754, meaning that it's above 0.7, which is good. So it means that this is actually an acceptable reliability value. Yeah, I've just selected the Cronbach if the item is deleted, which is, if you want to go in more depth in doing item analysis, you can have a look at that. But if you're using an established scale, it is fine to just look at the actual Cronbach alpha and report that in your study. Okay, so for reliability testing, we're going to do reliability analysis on the patient satisfaction scale. So for that, I'm just going back to my SPSS. And so you will see, if we go back to the variable view, I just want to show you that these variables, complaint procedure, cleanliness, all of them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, they all Likert scale items, and they all measure patient satisfaction. All right. So I want to do reliability analysis on those items. So what I do is I go to analyze, and then I go to scale, and then I select a reliability analysis. Okay. And then I now can select these 10 items. I can shift and move it down and select all of them and just move them over to that side. When it comes to statistics, you can select statistics if you want to. I sometimes select item and scale if item deleted. I will show you now why I do that. And then usually it's an alpha. There's these different ones, split half, Gutman, parallel, whatever. I usually select alpha, and then you say, okay. So what you see here is that the reliability statistics for the Cronbach alpha for this 10 item scale was 0.781, which is acceptable. It's unacceptable. We can be fairly confident that the participants' responses are reliable and internally consistent. So meaning that the items in this scale is likely to consistently measure the construct of patient satisfaction, if that makes sense to you guys. And then what I usually do is I do have a quick look at this last column, which is Cronbach alpha if item deleted. Sometimes you get items, questions. What I mean by item is a question, okay? So sometimes you get questions that can actually is not appropriate and sort of changes your Cronbach quite a lot. So you don't want any of the items, if you remove it, to improve the Cronbach. If any of these numbers here were 0.8, for example, I would then wonder, okay, maybe this item maybe we should consider removing this item from the scale before we, if we want to, for example, calculate a satisfaction score, maybe we should remove that item. But in this case, there isn't really an item except for this one, the last one, waiting time 0.84, that slightly increases the Cronbach if I delete it. Yeah, I did also you can also do factor analysis on this and all of that. But I think for you guys, just to get sort of the gist of you know, what is a reliability analysis. Okay, so that is then reliability analysis, and we've got about 5 minutes left. Reliability testing. And so yeah, I just want to, is it now the wrong slide? I actually want to, there's one I wanted to ask you, is maybe I can just ask if there's any questions anybody has at this stage. Any questions that you have related to analysis? So again, as a supervisor, you don't have to do this for your student, but it's good to just have this background because it will really help you to assist your students. So I've got a last activity that I wanted you to do, but I, for some reason, didn't have it here. So I want to quickly ask you guys if you want to use the poll. If you use this link, poll EV, if you click on that and you open it in your browser, if you can tell me, how do you feel about doing descriptive analysis in SPSS as a final word? If you all can see the poll EV link, you can just click on or copy that link, put it in your browser, and then you can type in there how you feel about doing descriptive analysis. I'm just going to give a minute or so because I know we've got another meeting. Much better. I'm happy. I'm very happy. So if there's any one of you, you can still type in here. If anybody has any questions about SPSS, if you feel, is there maybe anything that you want to know more about? Mariana, I think we will probably do another needs analysis as we continue to just see where people still need some assistance with, yeah, better. I'm very happy that everybody's feeling better. That's good.
No, Talita, thank you. I think it's a very valuable lesson. I enjoyed it, and I believe that once everyone has the software on the computers, they will obviously use it and engage with the students' data set. That's what we really want them to do. Thanks, Talita.
Thank you, everybody. I'm going to stop the recording now.